For this video, we're going to be reviewing prime factorization and finding the greatest common factor. When finding prime factorization of a number, we have to ask ourselves, what can I multiply together to get this number? So when we're dealing with 32, we're going to say, what do I multiply together to get 32? If you can't think of a multiplication fact off the top of your head, you can go through your rules. We know that 2 is definitely going to go into 32. Because it's an even number. And if I'm not sure how many times, I have to do my division. 2 goes into 3 one time. 2 times 1 is 2. Subtract, bring down. 2 goes into 12 6 times. So 2 and 16. We also know that 4 and 8 work. You can do either one. You're going to get the same answer. So 2 times 16 gives me 32. This is when you need to have your first few prime numbers memorized. 2, 3, 5, 7, 11, 13. That's going to be really helpful when doing this. If you get to a prime number, you want to circle it. 2 is prime, so we're going to circle it here. There's nothing more we can do with that. But 16 is not a prime number, so now we have to take this even further. What can we multiply together to get 16? 2 times 8. Again, 2 is a prime number, so I circle it, but I have to keep doing my 8. 2 times 4. 2 is a prime number, 4 is not. So I have to keep going. 2 times 2, and those are now both prime. So now I'm down as far as I can go. So I can rewrite that as 2 times 2 times 2 times 2 times 2, or 2 to the 5th power. That is the prime factorization of 32, or a factor tree. Let's try another example, 120. What can I multiply together to get 120? Because it ends in a 0, we know that 10 is going to go into 120. 10 times 12. Neither of those are prime numbers, so I have to continue to factor them out. To get 10, I can multiply 2 times 5. Both are prime, so I'm going to circle them. 2 times 6 gives me 12. 2 is prime, but 6 is not. 2 times 3 gives me 6, and both of those are prime. So I can rewrite this. When we rewrite it, we want to go from smallest to biggest number. So I'm going to start with my 2's. 2 times 2 times 2. Then my 3. Then my 5. 2 times 2 times 2 times 3 times 5. Or we can shorten it even more. 2 to the 3rd power, because I have 3 2's, times 3 times 5. The reason prime factorization is important is because we can use those skills making factor trees to find the greatest common factor between two numbers. So what we would do for this is when given two numbers and asked to find the greatest common factor, we have to start by making a factor tree for each of the numbers. So 25 is 5 times 5. Both of those are prime. So I'm going to rewrite that down here as 5 times 5. 100, we can do 10 times 10, which can be broken into 2 times 5. And those are all prime. So I'm going to rewrite that. 2 times 2 times 5 times 5. Now, to find the greatest common factor, we need to find pairs between these two sets of numbers. So this 5 can match with this 5. And since they're one pair, I'm going to write it down once. So a pair of 5s gets written down once. This 5 can match with this 5, and again I'm going to write it down once. So 5, or now if we look, these 2's, they don't have a pair, so there's nothing we can do with them. We're going to ignore them. So to find the greatest common factor, we do 5 times 5 equals 25. So my greatest common factor is 25. Let's do one more example. We can get 27 by multiplying 3 times 9. 3 is a prime number. We can get 9 by multiplying 3 times 3. 3 is a prime number. I'm going to rewrite that 3 times 3 times 3. Now let's do our prime factorization for 81. 9 times 9 is 81. And I can break both of these into 3 times 3, which is a prime number. So I'm going to rewrite that as 3 times 3 times 3 times 3. Now, to find my greatest common factor, I'm going to look for pairs. A set of 3's, write it down once. Another set of 3's, write it down once. Another set of 3's, write it down once. And this 3 over here does not have a pair, so I'm not going to worry about it. And then I can solve. 3 times 3 is 9, times 3 is 27. So my greatest common factor is 27.